Hello, scientists! It's a rainy day, so I'm inside baking a cake. Let's see. I need flour, eggs, sugar, water, vanilla, and a pinch of salt. Mix it together and then put it in the oven at 350 degrees. And now we wait. See, all those ingredients together make up our cake. And you know what? The same kind of process made this rainy weather outside. Just like the cake, the weather is made up of a lot of ingredients. Sugar, eggs, flour. Oh, wait, that's the cake recipe. Here's the weather recipe. Temperature, clouds, precipitation, humidity, air pressure, and wind. How many of these do you already know? Well, let's start with temperature. Temperature is the measure of how hot or cold the outside air is. And you know that this can change frequently. It's usually cooler at night than it is during the day. And of course, it's colder in the winter and hotter in the summer. Next, we have clouds. I just love looking at shapes in the clouds, don't you? Look, there's some cooled water vapor in the shape of a blob. And there's a blob of cooled water vapor. So I'm not really using my imagination to see shapes. But that is what you're seeing when you look at clouds. Cooled water vapor. Clouds are bunches of cooled water vapor in the air. But how did it get up there? Well, as the sun warms the Earth's surface, some of the liquid water evaporates into gas. That's water vapor. As the water vapor rises, it reaches the cooler air way up in the atmosphere, where it forms clouds. But as the vapor cools more and more, it turns back into water, which means precipitation. Precipitation is any form of water that falls from the sky, like rain, hail, or snow. Next, we have humidity. Humidity is a measure of the amount of water vapor in the air. You can feel this in the summer on those hot, sticky days. The air is actually holding water vapor. Then we have air pressure. Air pressure is the measure of the weight of the air in a particular area. That's right, air actually has mass. When we say the air pressure is low, it means the air molecules are spread out, which means the air is lighter. But if we add pressure, that means more air molecules are crammed in. Now the air is heavier. But what about when the air moves from a crowded high-pressure area to a more open, low-pressure area? Well then, we get wind. Wind is moving air. And sure, a fan can make the air move. But it also happens on its own in nature. This is because of differences in air temperature and pressure. Warmer air rises and cool air sinks. So this warm air rises, meaning there's less air down here now. That area now has lower air pressure. And over here, this air is colder, so that sinks. Now this region has more air, higher air pressure. But look, now all this air is crowded. And over here, the air molecules are spread out. They've got plenty of room. Air tends to move from areas of high pressure into areas of low pressure. So air from here rushes into all this space. And when that air moves, we get wind. Look, our cake is finished. That tastes good. That's a lot of ingredients. Now you can see why the weather is so hard to predict. If any of these ingredients changes, it means big changes in the weather. And the weather changes all the time. When I was making the cake, we had to measure each ingredient, right? Well, scientists have to do the same to measure all of the ingredients of weather. And no, they aren't using measuring cups to do it. They've got some really unique tools to help them investigate the weather. But guess what? You can build them too. In this lab, you're going to discover ways to measure the weather. Enjoy!